cation exchange capacity in a soil itself is influenced by the type of clay, the amount of that type of clay, and the amount of organic matter present. So this table shows you the cation exchange capacity in a soil. Well, I'm sorry, it shows you the cation exchange capacity of clay minerals and organic matter specifically. All right, so it shows you that kaolinite has a relatively low CEC, and then mica, which is a 2-to-1 type clay, montmorillonite and vermiculite, which are both 2-to-1 type clays, have varying cation exchange capacity, but they're rather large as compared to kaolinite. So this is a 1-to-1 type clay, and these three are 2-to-1 type clays. Organic matter has a CEC of about 200. And when you think about this, you know that soils are not 100% clay, or they're not 100% of any one of these types of clays. There's oftentimes a mixture of other minerals besides clays and organic matter, which brings down or dilutes the overall cation exchange capacity in a soil. So another way of looking at this is this way. That cation exchange capacity is affected by texture, right? So this is the dilution of the organic matter and the types of clays, or the amounts of those types of clays present in soils. So if you're to look at soil texture, light colored sands versus dark colored sands have a range of CEC between 2 to 4 and 8 to 16 roughly. Loams, silt loams, clay and clay loams, this is becoming finer and finer in texture. So smaller and smaller particles, i.e. more types of clays present, and subsequently the CEC increases. And then you have organic soils that might have a CEC between 50 and 100. And so let me give you an example. So this is a soil test. It's actually from Colorado. I'll have to hopefully change this in the future to show you a soil test from the Midwest. But this, regardless, this still drives home a relatively important point. So if you look at this soil test, there's 6 different soil samples that were sent into this lab for testing. They're from 2 different fields, a tall field and a short field. And here are the depths of the soil samples in inches. And here's the pH. So it's alkaline. And if you look throughout this, do you see anywhere where it says texture? It doesn't say texture anywhere, but it certainly shows the cation exchange capacity in milliequivalents per 100 grams. So if we zoom in on this, this is zoomed in, and you can see this texture, or this CEC, ranges from about 25.5 to about 29. So based on the CEC, what do you think the soil texture is? Well, you can go backwards a couple slides and look at this slide. And if you look at this slide, as compared to the values that are circled on this slide, this soil is likely a clay or a clay loam. And to me, that's not surprising after living in the Western United States for so long. But if I've lived in Ohio for a little while, and if I found a soil test result that showed me only CEC, and I had to determine soil texture based on the cation exchange capacity, I could do it. And I could actually look up that soil if I knew the location of the where the soil was sampled. I could look it up on Google Earth with this soil web overlay, and it would tell me what the texture is of that soil. And so what I'm doing here is, and maybe you're getting this idea. When I teach this class, I talk about the puzzle, and I'll likely talk about this again in subsequent videos, but this is the puzzle of soil, and specifically the puzzle of soil fertility. That if you know one item, you can estimate or derive another item within the soil, or a characteristic of that soil. And in this case, if you knew cation exchange capacity, you could likely estimate the soil texture. And if you knew the soil texture by doing texture analysis via hydrometer or pipette method in a laboratory, maybe you've done that before, or texture by feel, sometimes it's called the field method, it's outlined by the NRCS. If you knew the texture, you could estimate the CEC. You could go backwards and forwards here.